In this video, I'm going to talk about how to use a Hugging Face model to run model-assisted labeling and active learning on your NER data. We're going to walk through a code example to see how you can leverage a third-party model to pre-label your data stored in your model run. Then we will visualize the model predictions and confidence scores before submitting them as MAU for your labeling project. Lastly, we will show how you can further automate the model-assisted labeling and active learning step with a one-click model inference API integration. And now hopping over to the Colab notebook, which we will also share together with the video. The step one is to prepare and upload your data rows to Labelbox. And here we don't have any ground truth annotations yet. We will start with uploading all of our data, which is stored in a Google bucket, to our Labelbox dataset via delegated access. And by the end of this step, you will be able to see the dataset loaded in our catalog, and you can inspect into each dataset. So coming back, we're also going to create ontologies based on this particular dataset because we're doing an NER task. This is a common NER ontology we're going to use. This ontology will be used for both the project and the model run to indicate what the model predictions should look like. And next up, we're going to create a model run that contains all the data rows, and we can run an inference experiment on them. So using the data rows we just created, we're going to create a model called Wiki Neurotext NER Inference, and we're also going to create a model run. And here we upload all of the data rows. We're also going to specify all the hyperparameters we're going to use for this particular inference experiment. In this case, I need to specify what the model type I'm going to use and what the tokenizer type I'm going to use, together with the batch size. And once we have that, the model run now contains a version dataset for this experiment as well as the hyperparameters. After this is done, we can actually hop back to our models page and check out the model run we just created. You will be able to see all the data rows loaded, and you can also check out the model config. And if you want to change anything, you will be able to adapt them there. So going back to our notebook, we're now ready to build our Hugging Face pre-trained model pipeline. And the way to do that is simply loading our model run config and use the model type and tokenizer type to specify what NLP pipeline you want to build using the Hugging Face library. After this, we're ready to do inference on our model's data. We're going to export the labels from our model run, download the raw text data for the model input, and here we're essentially doing the batched inference on all of the model run data. And here is the sampled model results for one of the data we ran through the model. It looks good. And now we're ready to upload the predictions back to model run so that I can inspect my predictions further and check out their confidence scores. We're going to upload the predictions. We're also going to upload the confidence metrics back to model run. Once this step is done, we're now ready to go back to the model page again to inspect them. And here we can see all the data rows with predictions in the detailed view. The red dotted lines showcase the predictions from the model. We can also see the metrics over here to check out the confidence scores across this data row. Here the model is very confident for all of these, probably because the model has been trained on this particular data set. We can also look at the metrics tab. Here it gives an overview of all of the model's metrics. We only have confidence scores here, but that gives an overall preview of how the model is performing on each particular entity. And again, the model, as you can see, is highly confident in its predictions. So I want to talk about an active learning procedure. So usually one way to do active learning is to select the model's low confidence score data rows, because those are where the model is struggling the most. So if I'm selecting the low confidence scores across all of my feature, and I say I want everything that's lower than say 49% to regard these as low confidence score data, I can actually prioritize labeling on these data so that I can improve my model performance next. So I'm going to select all of these and I'm going to send to a project as batch. Here I already have a wiki, a neural text NER project, and I'm gonna say here is a batch of low confidence batch, and I'm gonna assign priority to them. I'm also going to use the predictions as my model assisted labeling so that labelers can reference the model predictions. So once I say submit batch, it will send them as batch, so I can start labeling on this low confidence score data rows to improve my model performance next. So now that we show the whole process of how to use a Colab notebook to run model-assisted labeling and active learning, I'm then going to show you how to automate further the whole process with a one-click model inference integration. So here I'm actually going to use a cloud function on Google as an example. It is agnostic to any compute services and backend you use, but here the most important thing is our model API allows you to create an endpoint called model run on your own compute backend, which implements the inference functions. So here the inference function I use is essentially all the logic that I used in this notebook, but copy paste over to this cloud function so that it can be triggered upon demand. So here, once we created a model endpoint integration that's pointing to my cloud function, I can just click this button. It is going to first query the endpoint of what machine learning models or type of model that's available. In this case, I created Hugging Face inference for NER, and once I click confirm, it is going to receive this payload of model run data and trigger the cloud functions here. So at the end of this cloud function, it will actually upload all the model predictions and active learning related scores such as confidence scores back to our model run, so that once you create the script, you can just use this one-click integration to run your future model experiments.